Hello, hello, good people of pre-calculus. The next unit is going to be about exponential and logarithmic equations. And so we're going to begin today by solving for x when x is in the exponent. Let's go. All right. Everything today is going to use something called the one-to-one property. And what that means is you want to make the bases equal to each other. The base is the number that's holding up the exponent. So the base on this side would be a 3. So what you want to do is you want to rewrite this side so that it is 3 to the power. Now, this requires that you know the powers of 3, right? In the case of 81, 81 is equal to 3 times 3 times 3 times 3. So it's equal to 3 to the fourth power. Hopefully, you can figure that out. And if you can't, you can always use one of these sheets that has exponent facts on it. All right. So I'm going to leave the left side the way it is, and the right side I'm going to rewrite 81 as 3 to the fourth power. And now what we're going to notice is that because the bases are the same, that means the exponents have to be the same. Therefore, our answer is going to be that x is equal to 4, and we're done. Okay, let's keep rolling. Take a look at number 2. On number 2, my base on the left side is a 2. So I want to rewrite this so that it's 2 to the power. And so this means we need to talk a little bit about how fractional exponents work. A fifth root means the same thing as the 1/5 power. So I'm going to leave this side as 2 to the x minus 1. Over here, I'm going to write this as 2 is raised to the 1/5. Okay, so you see a root, you write it to the 1 over whatever root it is as your denominator power. Therefore, x minus 1, 1/5, they're the same thing. If x minus 1 is equal to 1/5, and I add 1 to both sides, that means x is going to be equal to 1 and 1/5. Or if you're feeling improper, you could call that 6/5. Move along to number 3. What else do we have going on? Ooh, we've got a fraction this time. Okay, fractions. Let's talk fractions. Over here, we have a 4 as our base. Now, you might be tempted to say, hey, I see a 64 right here, and I know that 64 is 8 squared, right? That is true. However, 8 doesn't get us where we want to go. We want a 4. So what you need to figure out is that 4 times 4 is 16 times 4 is 64. So 64 is 4 to the third power. Okay, so I could take this side and I could rewrite it as 1 over 4 to the third power. But that doesn't quite give us what we want because we need 4 to the power. So what we're going to do is we're going to grab this term in the denominator and we're going to scooch it up to the numerator. And as you guys learned in Algebra 1, if 4 is having a positive experience downstairs, when you move it upstairs, it's going to change the sign. It's going to have a negative experience. So this becomes 4 to the negative third power. All right, so see how now we have the same base on both sides. That means that our exponents, ba-boom and ba-boom, have to be the same. So x, if you add 3 onto it, you get negative 3, which means subtract 3, x is going to be negative 6. All right, scooching along. Let's take a look at number 4 here. This is the example of a problem that could have more than one solution. We start by noticing our base is 3. So we want to rewrite 27 as 3 to a power. That would be 3 raised to the third power. Therefore, x squared plus 2x and 3 are the same thing. And now you do something we've done 1,000 times this year. Scooch the 3 over so everything is set equal to 0. And then factor this bad boy into x plus 3, x minus 1. So x is going to end up being negative 3 or 1. There's our answers. All right. Bum, 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 bum. Let's scooch on over here. This one's always one of the trickiest ones, right? You've got a 1 right here. What on earth do you do with the 1? Well, you want to use the fact that there's this property in math that says that any base, I'll call it b, raised to the 0 power is 1. Therefore, one way to think about this problem is, since 2 is the base on the right side, and I want this to have a base of 2, I could write this as 2 to the 0 power is equal to 2 to the x. And now we know that 0 and x, same thing. Okay. One more right here, number 6. We see a 5 in the base. So we think 125. How do I write that as 5 to a power? Well, 125 is 5 times 5 is 25 times 5 is 125. So 5 to the 3rd power is 125. So now this is equal to this. Subtract that 1 from both sides. I get 3x is equal to 2. Divide by 3, and x is equal to 2/3. All right. Go to the second page. Here's what I'm going to do. I want you to pause the video, and I would like you to try example 7 and 8 and 9 and 10 and 11 and 12. Pause the video right now, and then when you come back, we are going to check our work. All right. So unpause. I'm going to give you the answers now. And if you've got the problem right, great. Give yourself a pat on the back. You're done. Answer to number 7 is 3/2. Answer to number 8 is -2. Answer to number 9 is x is equal to 2/9. Answer to number 10 is x is equal to 1. Answer to number 11 is x is equal to 4. And the last one, 12, the answer is x is equal to 3. So if you've got all 6 of those correct, you are done for today. And you can go to WebAssign and attempt the preview there. If you didn't get any of these right, I want you to move the video to when I do that problem and go through it with me. So I'll begin with number 7 right here. On number 7, the first thing you want to do is note that this is 8 raised to the half power. And then the second thing you want to notice is that 8 is 2 to the 3rd. So this is 2 to the 3rd to the half power. Exponents, when you have parentheses, they multiply. So 2 to the x is equal to 2 to the 3/2, which means x is 3/2. Moving along, number 8. First thing you want to do is rewrite 0.25 as 1/4. Next thing you want to do is say that 1/4 is 1/2 squared, which means it is 2 to the -2. Therefore, x is -2. Moving to number 9. Okay, I'm going to kind of one-step this one. I'm going to call this 7 squared. That's what the 49 is. And then the 9th root means that that is raised to the 1/9 power. Therefore, 7 to the x is 7 to the 2/9. We are multiplying, which makes x equal to 2/9. Take a look at number 10. On number 10, we have bases on both sides. You have to pick one. I usually pick the smaller one. So I'm going to say, let's make 2 our base, and therefore we can take this 4 and write it as, oh, I almost wrote 4 again. Pretend that's a 2. Oh, hang on. I got you. Oh, yeah. All right, there we go. That 4 is 2 raised to the 2 power. Now, the exponent on that is x plus 1. So all of this is getting multiplied by x plus 1. On the other side, we have 2 to the x plus 3. So 2 times the quantity x plus 1. Once again, that's because this 2 is affecting the entire exponent that 4 had, is equal to x plus 3. You solve that equation by saying 2x plus 2 is x plus 3. Therefore, x is going to be equal to 1. I'm moving, I'm grooving. Right here, we have E. Fun fact, E is approximately 2.718. It continues after that. More on this number later on. But this one is literally as simple as saying, I know the exponents are the same. So 2x equals 8 means x is equal to 4. And the last one, just a little bit different on this one. This one, you got to get the 2 to the x by itself first. So that means subtract 5, subtract 5. 3 times 2 to the x is equal to 24. Still got to get the 2 to the x by itself. What is the 3 doing? It's multiplying the 2 to the x. So we're going to divide. We're going to do the inverse operation. That gives us 2 to the x is 8. 2 to the x is 2 to the third. X is 3. And we're done. Go get that web assigned, ladies and gentlemen.